Have joined that I may not know. My name is Maria Smith. I'm the Viticulture Outreach Specialist with Ohio State University. Yeah, as Todd had mentioned, we're all still working from home, but OSU gave us these nifty Skype for business phones that connect to our computer. So now we're accessible fully remotely in the same manner that we were in our offices. And for that contact information, you can find it down here below, my email address, my office phone number, as well as our website, which is go.osu.edu/grapes, where this presentation and workshop, as well as other virtual workshops will be hosted. Okay, so I wanted to bring up a couple of reminders before I get going on the 2020 season. The first is that our 2021 Ohio Grape and Wine Conference, which is going to be virtual again, or like everything else this year, virtual, will be held February 15th through 17th. So if you have not registered for that yet, please do so, because all of the keynote speakers videos will be going out a couple of weeks ahead of time so that you can view them and prepare for the live Q&A sessions that will be held on the 15th through the 17th. The annual Winter Grape School is going to also be virtual this year, which means it's not limited to the Northeast Ohio region. It will be a statewide event, and that will be held March 4th, as well as our pruning workshop, which again, traditionally is in person, but will be virtual, similar to last year at the start of the pandemic, and that's going to be Wednesday, March 10th. For registration for all of these events and event information, please visit our website. I copied the link to it right here. It's under the events tab of the website. Okay. I also wanted to acknowledge our team at OSU, both in viticulture with Ahmed Damey, Andy Kirk, Gary Gow, Diane Kinney, Lorena Brown, and Yvonne Woodworth, as well as the Ohio Grape Industries Committee, with support for this workshop. And also thank you, Todd, for inviting me to participate with you. So today is going to be all about white wines. As Todd had mentioned, next Tuesday, same time, same link, is going to be on red wines. And again, this is going to be the 2020 season overview, as well as vineyard issues that I had observed and encountered from others that may have impacted your processes in the winery for this past fall. So the three major events of the season beyond COVID were the spring freeze and the delayed start to the growing season. That obviously was a massive concern for everybody in the state. Fortunately, for at least the Northeast and the northern part of the state, they skated on by that with very minimal damage, but the rest of the state did definitely suffer from that. The second was not just the freeze, but also the rain, as well as those continued cool temperatures, which definitely caused some early season disease related problems. And then once we were out of those cool temperatures, it was pedal to the floor, all sunshine, a lot of heat, but also a lot of drought, particularly mid-season, that sort of manifested itself in several different problems in the vineyard. So the ones that I wanted to address that were really pertinent to white grapes observationally happened to be the spring rain and cool temperatures, as well as mid-season drought. And I was going to refrain from talking about that spring freeze, several events, actually not just one single one, and the delay to the growing season next week for red grapes, because that tends to have a more profound impact when you're talking about varieties that ripen late and are red. So let's start by looking at the aspects of precipitation. This is just a graph showing the daily precipitation from January 1st through September 30th of this past year. And reasonably speaking, it was a pretty calm year, all things considered. Our largest rain event was less than 1.5 inches total on the day. And in contrast to previous years where we could easily have 4 to 5 inches in a single daily rainfall event, this proved to be a pretty tame year rain-wise. But the problem isn't necessarily the amplitude or the amount of rain that we receive in any given day necessarily for this year, but the frequency of rain, particularly early on. So one thing you'll notice is that the earlier you get into the spring season, particularly around March through June, you can see that it rains almost every other day. And then as we reach out of June and through the late summer and early fall, that daily rainfall tapers off into more periodic punctuated events versus daily rainfall. One thing that I wanted to note too is that at least for Unit 2 in Worcester, and of course you may differ based on your location and your variety, our onset of bud break was April 24th this spring. And that was for our Minnesota Cold Hardy hybrid grapes, Marquette and La Crescent. And then everything else followed. So going into a monthly precipitation, if we take the addition of all these daily events, sort of what do they look like, not just for this year, but kind of in comparison to the past several years, as well as to the 10-year average. And that 10-year average can be found in the last white bar on the right of each grouping, and the 2020 season in red right next to that. So again, take note of the precipitation, particularly in March, April, and May. March was well above average, but April and May were right around average, maybe a little bit less. And then we were pretty much below average rainfall through August of this past year. Compared to particularly rainy years, I think the benchmark for me is 2018. I feel like it just rained every day that year. We had significantly higher precipitation in those seasons. So again, 2020, relatively tame, but it did definitely cause some problems when you couple it with cool temperatures. And here's a look at those temperatures. These are the daily minimum in blue, and then the daily maximum above in red. As well as I put in a 32-degree freezing mark line, and this is just to demonstrate exactly how many freeze events that we happen to have, particularly right around the timing of bud break, which is demarked by this vertical line here. And as you can see, that definitely caused some problems because surrounding bud break itself, plus or minus 2 weeks, we had 7 events total that were below 32 degrees. And yes, that definitely caused primary bud injury in whites as well as red varieties. And then when we look at that temperature as a function of heat accumulation or growing degree days, which are, if you're unfamiliar with that unit, is the daily average temperature above 50 degrees Fahrenheit. And that's all additive across the year from January 1st through September 30th. Again, you can really see sort of the effect of that early season cool temperature as this heat accumulation curve falls well below the 10-year average for most of the season. And we don't even really catch up until sort of late season. Fortunately, we did have a very warm, relatively dry fall between August and October. So that helped significantly when we're talking about catching up to ripening length and ability for the year relative to the 10-year average. We maxed out right around that average with around 3,000 GDD, and again, this is Worcester, so your site may vary depending on where you're at, but we did max out right around that typical 10-year average GDD mark, which means at least for white varieties, we did not encounter any major issues regarding that early spring cold temperatures with the ability to actually ripen this fall. But one thing that was very problematic because of those cool temperatures and the amount of rainfall that we had in April, right around bud break, was phomopsis. And phomopsis is a really common disease that we get in the early part of the season. The species name is Phomopsis viticola. And the problem with phomopsis is that it can cause shoot breakage, weak wood development, fruit rot, and more importantly, the lesions where that disease develops along the shoot provides the overwintering spores and inoculum to infect in the next year. So not only can it affect your fruit quality if it happens to infect the flowers and the berries develop later on in the season, the symptoms for phomopsis, but then you're just setting yourself up for repeated cycles of this disease each and every season. So when I talk about cool conditions and wet conditions, the reason why phomopsis breakouts were pretty heavily observed this spring is because we were right in that optimum condition range, which is about 60 to 68 degrees Fahrenheit and greater than 6 hours of leaf wetness. So with all of that rain, there wasn't a lot of chance for the canopy to dry out, and it was pretty prime for disease development. So this bottom portion here talks about the cycle of the disease, and and how that works. When you have the pycnidia, you see those little yellow pin dot infections on the leaves themselves. That is from those pycnidia splashing up early on in the season. It infects the stem of the shoot. It infects the flowers as well. But again, those flower symptoms don't really show up until closer to veraison. The one sort of good spot, if you will, if that's even a thing when it comes to diseases, is the fact that secondary infections of Phomopsis are really rare due to the long length of incubation following that initial infection in the spring, which means unlike downy mildew, powdery mildew, and other diseases that occur later on, these don't keep cropping up. So once you have Phomopsis under control and you've passed a critical period for flower infection, Phomopsis tends to be much, much less of an issue. But again, given that the spores overwinter in the crevices of old wood, that can be a big problem for controlling this disease over the long term. I did provide a link to the fact sheet for Phomopsis down here on the bottom right if you want more information on control and management, or a more detailed description of how this disease biologically operates. So when we're talking about managing this disease, and again, here's that example of the shoot breakage and the shoot weakening from Phomopsis. Here is a great showing of those lesions on the shoot itself. And you can see the yellow stippling and the crinkling of the leaves. These occur primarily in the bottom part of the leaves, or in the bottom leaves of the shoot and in the base of the shoot, where you happen to be closer, especially if you have old wood in the cordon and old wood in the trunk, you're closer to the spore source. And again, because it infects so early in the season, and only has one sorry, dogs. Only has one major infection period per season. Really sticks to the bottom portions of a shoot. Keep in mind that symptoms of Phomopsis and anthracnose look very similar. One thing that can characterize Phomopsis over anthracnose is the fact that these little yellow lesions that pop up on the shoot or on the leaves can and do tend to form little pin dot holes that fall through. Those are called shot holes, if you will. But the lesions on the stems look incredibly similar, and they're both early season diseases. The fruit symptoms do look very different. In anthracnose, fruit symptoms do tend to pop up earlier than Phomopsis. So that could also be a way to differentiate them, but the control of the diseases are both very similar in terms of making sure you're performing good sanitation. So if you do have infections of Phomopsis in particular that happens to overwinter in old wood, if you had a severe outbreak of Phomopsis, it might be a good idea to replace older wood, especially cordons, if they happen to be, say, more than 5 years old or so. And to try to prune out as much of the infected cane wood that you can that may be harboring those as well. So for instance, if this shoot were to lignify and become woody, that goes from a shoot to a cane, but that cane still has these pockets of lesions on it that will be used as the inoculum to infect in the next season. So the more that you can prune this out, the better off you're going to be in terms of the disease control and reducing the inoculum. And then when you have seasons like this one, where you happen to have frequent rainfall events, high leaf wetness, I would suggest decreasing your intervals for early season protectant fungicides. Again, that's mancozeb is the primary ingredient that we use early in the season as a form of green tissue protectant until the leaves are old enough to be able to absorb more systemic fungicides. And that's what we tend to use closer to the bloom and critical period for great protection from diseases. But we also know that mancozeb washes off really easily in low volumes of rainfall. So you can lose the majority of your mancozeb within, a tenth to half an inch in rainfall. And so if you apply in more frequent intervals, even if you use a lower concentration, you're still getting more effective protection than if you use one large application less frequently. Okay, so let's shift gears into a little bit of the later part of the season where we started to see drought conditions. And again, this goes back to that precipitation monthly accumulation chart, where you can see after about April, May, June, rainfall drops off significantly in the month of July. We had less than about 1.5 inches total accumulation across the entire 31-day period of July. And that caused widespread drought, even though it was mild to moderate across most of the state. The couple of exceptions, of course, were Northeast, where you guys had a bit more rainfall than we did over the month, as well as Knox County, parts of Delaware County, Columbus area, into Muskingum. So, this causes quite a bit of problems for us when we do experience drought conditions. We don't typically think of Ohio as being a drought-stricken state, but because of the typical average rainfall and the distribution of rainfall we get each year, we're not a state that typically bothers with irrigation. And that, of course, is a problem for young vines, especially, who don't have as deep and as established of root systems. So they tend to experience much more drought stress than mature established vines. But we also saw quite a bit of nutrient deficiency as a result of drought too, mostly in the form of nitrogen, potassium, and magnesium. And part of that is because water is used as a basically as a solubilizer for these nutrients. Water also provides mass flow of these nutrients from the soil solution up through the root. And all of these fluid mechanic components, if you will, basically slow down and decrease under drought conditions. And as a result too, of course, plants use water to transpire, and if there's no or decreased transpiration, then you also get decreased shoot growth as a result as well. And so having that typically manifests itself into leaf symptoms as nitrogen forms the backbone of amino acids and proteins. Phosphorus is an incredibly important component to lipids, as well as energy storage in the form of adenosine triphosphate. That's the primary energy storage molecule in organisms. Nitrogen and phosphorus are both in DNA. Chlorophyll is nitrogen and magnesium, which is why you typically see leaf chlorosis symptoms. And then potassium, which is probably the most critical from a winemaking perspective because it's responsible for osmotic regulations and water relations within the vine. So in fact, we did see quite a bit of chlorosis, again, especially in younger vines. It might have been more exaggerated. If you happen to have a stressed vine from a high crop level, that could also exaggerate some leaf symptoms as well. Again, some repercussions and what this could mean for the harvest. Again, stunted shoot growth, early defoliation, and as a result, poor fruit maturation. Just because you don't have the photosynthetic leaf area that you need to functionally ripen that unit of fruit. And then one thing that was really, I don't know if you call this cool or not, but observationally interesting, I guess, is the effect that it had on yeast assimilable nitrogen. And I know that Paul and I had conversations about this earlier this year at our workshop in May, and I think it's kind of nice that it comes full circle here in January. But I did notice from several growers across the state, and not in any one single variety, and several different white varieties in particular, that there was very low YAN in that must when it was analyzed. And we're talking about as low as 35 milligrams of nitrogen per liter. So when we're talking about YAN, yeast assimilable nitrogen, or that nitrogen, is a primary nutrition source for yeast during fermentation. And white wines typically require about 125 milligrams of nitrogen per liter in order to maintain a healthy fermentation. Of course, this is dependent on your yeast strain as well. And low YAN can really increase the risk for sluggish fermentations, as well as hydrogen sulfide problems as a result of that yeast stress from not being properly nourished as it's pumping out its alcohol and fermenting. But I wanted to leave any recommendations for testing YAN, or if you want to do it yourself, you can. I wanted to leave that for Todd to talk with you about individually if you happen to have that problem, or if you're not even aware that you have that problem, but you notice that you happen to have H2S in your wine and you wonder if that could be a factor that contributes towards that, as well as any adjustment recommendations. And even when you supplement with YAN to get up, or with nutrition products to get up that YAN level up to 125 milligrams per nitrogen, of nitrogen per liter, you can still have problems with your fermentations. And another thing, because of the potassium situation and its function as an osmotic regulator, it can cause fruit pH issues, and it can also cause color stability issues. As we know that high pH in must can cause precipitation of anthocyanins and color pigments in the wine. And then lastly, we know that nutrient imbalances in the vine have been associated with pre-harvest berry shrivel in some varieties. So if you see sort of an unnatural shriveling that isn't necessarily caused by drought itself, it could be associated with potassium imbalances or nitrogen imbalances in the vine. So the way to combat these issues is by making sure that you're monitoring your vine nutrient status, your YAN values every single year, because we know that these can happen under several different conditions, whether they be related to the crop level or the weather or any other factor that might be going on. So please make sure that you're testing every single year your vine nutrient status. And then soil sampling should be performed both pre-planting as well as once every 3 to 5 years post-planting, or more frequently if you've been continuously adjusting for, say, like soil pH factors or any other nutrient adjustments, for making sure that your soil is long-term adequate for good vine growth. So we do have a fact sheet on how to monitor your vine nutrient status that can be found here in this link. We know that so many factors contribute to annual vine nutrient status, which is why we suggest you check it on an annual basis, because when you do check it, you can modify it within the same year. So if you're only going to perform vine nutrient status, sample at veraison. That's when the most nutrients tend to be the most stable in the vine. And if you're planning to sample twice a year, sample at bloom and at veraison. That way, if you do modify any sort of short-term foliar application of fertilizers, you can recheck the effect that those happen to have at bloom time in the next season. In the East, we recommend sampling petioles because that is the long-term standard valuations that we have for vine nutrient status. If you were to just Google vine nutrient status and you come up with, say, like UC Davis or Washington State's website on how to monitor it, they tend to use leaf blades. We don't have the long-term historical data necessary to be able to corroborate those values, which is why we continue to use petioles as the standard sampling method. So again, short-term fixes for nitrogen, magnesium, potassium, phosphorus, they all exist as long as you're using a soluble form. Make sure that you're not tank mixing them because sometimes fertilizer additives can cause toxicity with fungicides and other chemicals. But for the long-term fix, the really only good solution is making sure that your soil pH and your soil fertilization is on point. It does take way longer to amend and adjust those values compared to just spraying on foliar fertilizers, but the long-term benefits way outperform short-term fixes. So that's the bulk of what I had. I'm going to turn it on over to Todd. Again, any questions that you have during during this presentation will be addressed after Todd. So let me turn that over.
Okay, can everybody hear me okay, Maria?
Yeah, but you're not sharing your screen.
Okay, let me see if we can. I thought I hit that button, but let's see if we can get that going. Okay, hold on just a second. Anything now? Nothing
So
now?
Paul did ask about what growth ripening stage do you test for yan, and you actually test that in the must of the juice before you ferment. That tells you how much you need to add to make up for any deficits. And again, I mostly saw those very low values in white grapes as opposed to red grapes. But I mean, I saw it in La Crescent, in Chardonnay, in Riesling, and in several different white varieties. So those are going to vary by variety, by site, with insight. A lot of factors can contribute to differences in yan values. So that's why I suggest testing that every year, as opposed to testing it once and saying that's my typical value.
Maria, can you see the screen now?
Yeah, you just want to blow it up into your full
Yep.
presentation. But otherwise, you're good to go.
Okay. Well, thanks, Maria. Appreciate that good overview. And for those that just joined us, want to thank you again for participating in the virtual post-fermentation workshops. And as I noticed, or as I noted earlier, really from the enology side, it's really difficult to dictate what we cover in those regional settings because the wines drive the discussion. So, in addition to Maria's presentation on white vineyard practices that she observed and we all observed across the state, I thought, well, typically what we talk about a lot at those workshops are end up being essential wine practices. So I thought today I'd cover a presentation. I've talked in detail about different parts of these, but I kind of put it together for a presentation on essential white wine production practices. And next week we'll talk about essential red wine production practices. So with that, I'll go ahead and start. And hold on just a second here. Let me get rid of this screen. Okay. So again, I'd like to thank Dr. Maria Smith as well for her collaboration and her valued input on this, and also her IT assistance. As I mentioned before, I know enough to be dangerous on that, but certainly helps somebody that's a little better than I on some of the virtual new things that are going on now. But also like to thank the Ohio Grape Industries Committee for their support in our research at OSU in viticulture and enology and extension activities, like we're doing here today. So this just provides me with provides you with a brief outline and of what we're going to cover on essential practices. But first, I want to kind of mention a little bit, just a little what Maria talked about, but kind of in general, obviously when we look at white wine production or red wine production for a matter, obviously we got to look at the season. So that starts, early at critical points, like Maria mentioned in the spring. Is it looking to be good conditions at the time or relatively poor that we have to worry about disease pressure? Well, fortunately, we have good pathologists here at Ohio State, as well as Dr. Ahmed Damian and Dr. Maria Smith and Diane Kenny to talk about successful spray options and programs, because that's absolutely critical to come in with clean fruit, through the summer and going into harvest. Wildlife pressures, we all know, they can create damage puts us behind the 8 ball as well. So that's another issue that tends to be a problem. It could be from turkeys, deer. It could be um, raccoons, birds. Birds create a real problem, and sometimes it causes us actually to have to maybe take the grapes a little bit earlier on maturity than desired. So that's something we always have to keep in mind. Viticultural practices, I'm going to talk more about that next week. Not that they're not important for white wine production, but I'm going to talk about that more for red wine production next week, especially in the cluster thinning, leaf plucking, some other cultural practices there. Varietal characteristics, what varieties are we grown? Paying attention to Dr. Meddamy and Dr. Maria Smith as far as, putting varieties in the right place, the right areas for growing conditions. Are they early, mid, late season varieties? Sometimes that obviously is going to depend on our season or our vintage. So it's good to keep in mind because we need to have that window of idea of when those varieties are going to become ripe. So that way we can kind of take note of that and start looking at maturity progressions. And then grower vintner relationships agreements. That's a very important topic and worthy of discussion another time. We have discussed that a long time ago, but I think it could be of good importance to bring back up again. Looking more specifically at harvest parameters and the importance of that. I think it's essential that we keep in mind we have to be performing our standard harvest parameters of Brix, pH, and TA. However, it's not necessarily all we need to look at. I think it's important to provide sensorial monitoring as an important aspect in addition to these chemical analysis. So we want to look at determining that optimum maturity where we want to harvest the grapes. So with that, we'll follow that varietal character by picking out when we're tasting these maximum flavor and aroma developments in the vineyard while minimizing rot. We also have to keep in mind that there could be, depending on vineyard size, there could be specific areas of the vineyard where the maturity may lag. So that could be a decision, again, depending on the size of the vineyard. Is that an area where we're going to harvest a little bit later to make sure that we're a little more optimum on maturity? And can we do it with rot in mind? One of the ways that we looked at harvest maturity at the research center, Dr. Meddamy and I, is simply dividing the Brix by the TA. So I don't know if you can see my pointer here or not, but if we take a Brix of 21 that has a TA of 0.9 percent or 9 grams per liter, our value is 23. So the higher value represents typically an increased maturity. So that same variety at 22 with 0.8% or 8 grams per liter, we have a higher value there that we can keep in mind for helping us over the years determine optimum maturity. And that can be important to watch over the years and keeping in mind the vintage too. But that's one of the formulas we use there. Another, I guess, example of the fact that we can't look at sugar or Brix alone is a study through Dr. Glander when he looked at Vidal Blanc and looking at both aroma and taste. We see that for early, mid, and late maturity for optimum table wine production, we saw it was around 19 Brix. So it's not necessarily that magical 21 Brix number that we all hear about. So it depends on variety and when that variety is at its best aromatically and also sensorially on the palate. That could go for Niagara too. Niagara's one really, obviously we're looking at 12, 13 Brix, somewhere in that range, depending on acidity. Otherwise, if we get too higher in sugar content, then we're going to have too much of those fusel oils develop. So that's important. Here's another one I think for, especially for white wine, but also for red, that's real critical, I think, is fruit quality and microbiology concerns. So if we can all see the screen well enough, I don't know about you, but I'd much rather prefer working with the grapes on the left as opposed to what we have on the right. On the right, it's just going to put us behind the eight ball, and that old saying of you can't make a silk purse out of a sow's ear. I know everybody's heard me say that, and even Dr. Glander years ago. But it's so true. So, and one of the reasons why is because with increased levels of rot, we have increased enzymes like tyrosinase and lactase. So these cause browning and oxidation, as well as with lactase. It increases levels of glucan, which can seriously affect filterability. So proper use of certain enzymes in that case would be important. It also, as Maria mentioned, it elevates the must pH to greater than 3.5, which can be concerning for both chemical and microbial instabilities. This also can affect tartrate, protein, color, as Maria mentioned, and we see a browning of color, so we see more hue variant with higher pHs, and also maybe more importantly is SO2 effectiveness. But with these increased microbial populations, one of the real concern is that they can cause the depletion of our yeast assimilable nitrogen content, or YAN, that's needed for successful primary fermentations. And that's one thing that Maria mentioned there too. With the year that we saw some mid-season drought, we were coming in with low YAN values. But just keep in mind that with the more species diversity, or spoilage microorganisms presence, we're going to have more significant influence for the production of off odors and flavors. These are just simply some of the spoilage products that yeast, molds, and bacteria have been known to produce, and are certainly a concern. And this slide here is a real good slide that I like to show just the effect by Lonier in 77 that showed the increase of rot here. As it increases in rot percent, we see a direct correlation with the sensory score decrease on the right side. So that really shows us that, yeah, with rot, we definitely have a sensory reduction or reduce in quality of the wines that we're doing. So what are some of the things that we can do? Some of the preventative measures we can do, we can continually pick out rot in the vineyard. I think that's an important practice, so we don't have much in the cellar to do. And that way we're not infecting as much in the cellar also. Transport it out of the vineyard, as Maria mentioned, to avoid further contamination, and that would go for infected wood, like she mentioned as well. I think sorting tables are good in the wineries prior to destemming and crushing. And this, I believe this is worth the extra effort. If we don't have enough money for sorting tables, then I think it's up to the winery to figure out the best way to get that achieved. But we need to be working with the cleanest fruit as possible. And then if we do have rot present, I think one of the things we really need to pay attention to is sulfur dioxide use. I'll cover that more in a bit, but typically around 50 to 75 ppm would be recommended, and potentially higher for higher amounts of rot coming into the cellar. One other thing that we could do is consider whole cluster pressing for white varieties, which I'll talk about in a little bit, as well as thermal vinification to reds, which will be discussed next week. Lysozyme is another thing that we can add, especially in the case to protect against gram-positive bacteria or something like lactic acid bacteria. And we can also do some tannin addition. And tannins really can serve as an antioxidant in lowering the available oxygen to the microbes that are present. And maybe more even importantly, it can inhibit lactase activity as well. Oops, sorry about that. But what we really want to do is once we notice that rot could be a potential problem, we want to flag these tanks. We want to watch them from harvest to bottling. We want to pay attention to sulfur dioxide levels and make sure we're putting that at based on wine pH. So it should be around 0.8 parts per million molecular SO2 based on wine pH. And of course, as with anything, it doesn't have to be rot included coming in from the vineyard. We need to practice good sanitation and sterilization protocols in the winery. That's just critical, as well as sterile bottling that I will touch base on at the end. Another important thing, I think, and it really comes down to temperatures here that we see is harvest holding times and temperatures. I'm really not going to discuss hand versus mechanical harvesting too much. I think there's newer advancements in mechanical harvesting. We have more people starting to mechanical harvest. I think the older models did macerate fruit more so than the newer models can now, but it is a pricey investment, and obviously it depends on, vineyard size and that kind of thing. But there's some interesting work by Dr. Andy Reynolds that had done recently here with MOG, the effect of MOG, and he's going to present that at our virtual conference this year. So I'll let that more up to him and for discussion and lead into that. But really what's important here, I think, is the temperature. So we really want to harvest at night or morning so we have the coolest temperatures possible. And that's really to help minimize microbial activity. Really, this is true for both hand and mechanical harvesting. It's important to use sulfur dioxide at the time of harvest, especially with rot. We would say up to 75 to 100 ppm for the bins, especially with warmer temperatures that may be involved at harvest. This could be important as well to help prevent further microbial activity or breakdown. Really, they should be cooled immediately after harvesting, and that can be either done by placing the grapes in a chiller, maybe a reefer unit that you might have access to, whether it's in the vineyard or whether it's by the winery. A cold room or dry ice, snow pellets work great to create a CO2 environment and chill the grapes down as well. They use a lot of that out west. But really, we just want to minimize that time from harvest to the cellar, especially if we don't have the ability to chill those grapes down. I have seen some literature that would suggest that even alcohol production somewhere around 0.25% could be negatively affecting wine quality. And that is pretty significant there at that low a level. At the OARDC, for our varietal wines as well as research wines, we've always placed them in a cool or cold room around 38 degrees Fahrenheit overnight. That way we can start fresh the next morning. I think we're liable to make less mistakes and pay attention to sanitation protocols a little better by starting fresh the next morning. But it really just knocks microbial activity down, as well as promotes better must and juice chilling, as well as clarification that we'll talk about here in a little bit. Looking at white must processing procedures. This is just simply a whole cluster press that we have with, I think that's either Traminette or Vidal possibly. One of the things that we obviously need to do for the must that's critical is add sulfur dioxide. I would say anywhere, minimum from 30 ppm to 50 that with grapes that are broken down or are a little concerned for rot. Could be higher depending on the condition of the grapes. I think skin contact is a great option for extracting the desired terpenes and esters that we want to achieve from these aromatic varieties such as Riesling, Gewürztraminer, Traminette, Aramella, whatever it may be that we're looking to extract further aromatics and flavor potential. However, if we do have rot, this procedure, I would not recommend at all. We don't want to further enhance any microbial growth that could be problematic down the road, especially for fermentations. It's important to do skin contact at temperatures below 50 degrees Fahrenheit and with, approximately 30 parts per million sulfur dioxide in there to inhibit any oxidation or activity that might be going on. You can place them in a cold room or dry ice with snow pellets as well, which a number of wineries will practice that procedure too. As far as the contact time, that just varies anywhere from 6 to 24 hours or more. And again, it just depends on variety. For example, Traminette, with our experience, probably wouldn't recommend anything over 6, just because of the ability and what we're seeing to extract some of the harsh or bitter phenols that we can get out of Traminette. Whereas Riesling or Vidal or possibly Gewürztraminer, we can go up to 24 hours or even more, depending on grape condition and temperature. I mentioned briefly whole cluster pressing, and that's also good in hot years, or if we are purchasing grapes from warm or hot climates, just to help retain acidity. It does do that, as well as, again, we can save wine quality that has rot by whole cluster pressing. And one of the reasons it provides less insoluble solids. So it results in better juice clarification, which is better for retaining cleaner aromatics and that type of thing. Less microbial interaction of solids and activity there. But generally, we would say, hey, we want to provide a gentle pressing over compared to a high pressure over time, because we want to avoid extracting those harsh or bitter astringent tannins, as well as the phenols. And that could be either from the skins or the seeds, depending on how hard we're pressing or what type of press we have. So I mentioned juice clarification, and I really think this is one of the most important things that we need to pay attention to provide a quality white table wine. I know people have heard me talk about the importance of this before and on site visits, but it does make a difference in producing less potential for off odors such as hydrogen sulfide or even higher alcohols. We'll talk in just a little bit here. There are different settling methods that we can employ to greater or lesser effects, and also cost there can be looked at too. That might be a discussion for somebody on questions if they're interested. Looking at pectolytic enzymes, they're very important in my mind for white wine production, because they can extract some of the free and volatile terpenes. Some of these monoterpenes that we're interested in extracting, some other flavorants that are in the juice, but mostly around the skins and that. One example there could be Sin Free. It's a Scott Lab product that we've used a lot with good success. There's other pectolytic enzymes that can increase yields, that can increase, help with filterability. So it just depends, what we're looking at and the enzyme cocktail actually that we're using. One is an enzyme that might have beta glucosidase activity, and this can help release more free volatile terpenes. However, these enzymes actually should be added after primary fermentation is over, because they are inhibited by glucose, which is just something to keep in mind. We did a study a long time ago that did suggest that they do have some enhancement to help retain rosé color and stability as well. So that could be something of interest also. Just to show some importance of the last couple slides, this is a study that Dr. Andy Reynolds did at Brock, and he presented at our conference a number of years ago. But just looking at the free volatile terpenes, the potential volatile terpenes, as well as total, and in this case, they were looking at the addition of Sin-free enzyme compared to a control. We see both for free volatile terpenes as well as the total. We had a significant increase in those terpene levels with the use of sin-free. So that's going to lead to, better aromatic properties, increased sensorial fruit on the palate, that kind of thing. Another study of interest was one done that we did at Ohio State here, looking at the effect of different press fractions. So we have free run, light press, heavy press, and also looking at within that both clear and turbid juice. So in each case, in each press fraction, the turbid juice here had the highest amount of higher alcohols. Now these higher alcohols, really, we're not talking about ethanol. It's a higher molecular weight alcohol, such as isobutanol, butanol, those types of alcohols. They will mask varietal character. And so that's important to keep them low. And this also associates with low solids, which is mainly what we're looking at here. In a study we did with Pinot Gris over 4 years, we saw that the whole cluster actually had the less amount of solids over those 4 years considerably compared to, let's look at the free run up here, which was near 28% roughly on solids. So that's really significant. And a lot of people think the free run press fraction is the best. Not necessarily in all cases, especially with Pinot Gris that has lots of solids. We like to see less solids with this whole cluster pressing, nice upfront delicate fruit structure. However, I will say, depending on wine style and the versatility of Pinot Gris, for example, something done with like light press or moderately heavy press, we can get a little bit more complexity as we might see in Pinot Gris, or we might follow up with Surly. So we get a little more phenols in there as well. So that's something that we could look at there. Might age a little bit longer too with that increased pressing level. Obviously, other must additions at this time, chaptalization or sugar addition, any acid manipulations or bentonite for protein stability. These things I think are important to be done to the must. So really any large additions or subtractions should be done to the must, whereas we just fine tune the wine. I think we're going to have better overall quality to the final product by paying attention to those things there. It's going to be a little bit more stable product, most likely, in my mind, in my experience. Tannin addition, something that we can also add, as we talked about, just to lower the oxygen for aerobic microbes or inhibit lactase. Looking a little bit at fermentation management. Choosing Maria mentioned a little bit on Yan here and the importance of yeast strain, and that is important. But we see a lot of yeast strains on the market today, and a lot of them are geared towards, what types of varietal characteristics they provide, aromas, those types of things. And I think that's important, but I don't think that may be the most important thing or necessarily thing we need to look at. I think we need to look at actually, what's going to be the potential alcohol? Can that yeast strain, does it have the ability to survive higher alcohol contents? And that may be even more so on the red wine side. What's the temperature? That could be true to white wine fermentation. Can it have the ability to ferment at lower temperatures? What kind of H2S production does that yeast strain have? Or if we're performing malolactic fermentation, like in the case of Chardonnay or Viognier, we need to make sure that that has compatibility with the bacteria strain that we're going to utilize. But I think it's important to mix according to manufacturer's directions. That's going to help the yeast start out on a good note. And Maria mentioned the Yan. So in our mind and some of the research that we've seen, the minimal amount that we would like to see is about 140 to 160 milligrams per liter for yeast to do their job. Really a target of about 250 to 350 is desired. And that's to help create the proper biomass that we need for them to successfully complete fermentation and not drag out and possibly cause some off byproducts. Fermentation temperatures, I think, are critical for white wines to keep them low, keep them around 55 to 63 degrees Fahrenheit. We want to retain those fruity desired esters and terpenes. That's important. It's not saying that we're not going to develop esters or terpenes at higher temperatures. It's most likely not going to be the fruity esters or terpenes that are going to be expressed at lower temperatures in the fermentation. And then monitor our daily fermentation progress. Monitor for aromas, flavors. Are we getting anything off? Also for any indications that we might have a stuck fermentation. And then that way we can react or rectify the situation if needed. Some of the other things, like in the case, again, of Chardonnay or Viognier, or maybe a proprietary blend, barrel fermentation can be a great tool. It can provide a smoother integration of oak or oak compounds, provides more of a creaminess on the palate, and a little more mouthfeel and complexity. And that can be kind of combination with surly aging as well. But this also can be related to variety or wine style dependent. Although I've seen, some aromatic varieties like Riesling that have benefited with surly aging only if the lees is in good shape. So if there's any kind of rot or the pH is higher than desired, I certainly wouldn't recommend doing much in terms of surly aging. So no poor quality lees. Also, if we want to do a process like batonnage where we stir it once or twice per month to help release those manoproteins that add to mouthfeel effects, I think that we have to be careful that we're not stirring too vigorous, we're not causing too much oxygen entrainment into the wine, which then we're concerned more with A, masking varietal character, and B, worse would be oxidative notes or characteristics. We just need to remember that yeast aren't microscopic miracle workers. And really, if we don't start with grapes in good condition or proper harvest parameters, I think really the type of yeast we use doesn't make much difference as far as delicate aromatic choices. I think at that point, I'd want to get a yeast that's going to be a solid yeast to get us through so we can get sulfur oxide in there and protect the wine immediately after fermentation. Just a few notes on malolactic fermentation. Again, we don't know that, perform that quite as much as whites, but it is a way to lower down naturally the higher acidities that are present either in a poor vintage or with varieties like possibly some Minnesota varieties that are known for higher acidities. But we can inoculate either with the ability to do sequential or co-inoculation, depending on the temperatures. If it's early fall where it's a little warmer, I think sequential where we inoculate after fermentation is done or the tail end. But if it's a situation where it's late in the fall or early winter and, as a winery, we don't have the ability to perform temperature control as well, then sequential could be an option where we're adding it just after primary fermentation initiates. But we have to make sure that we utilize a yeast strain that is good for that is compatible with the bacteria that we plan to use. So that's really important, and producers can help us with that. Manufacturers of yeast and bacteria strains. Other conditions that are important, and I think vital, are temperature, 70 being optimum, pH, not necessarily lower than 3.1 or 3. Although we have strains out there now that I think are doing better on with lower pH environments, but still good to keep that up a little more. These are all good to keep a note. Or SO2. Some strains now are better with a little higher SO2 levels, but I would tend to plan to keep SO2 at a minimum or no SO2 for successful completion of malolactic. Again, carryover lees I think is good for nutrients for the malolactic bacteria, but nothing that has off aromas or we're concerned with other bad microbiology issues that could carry through. Rehydrate and inoculate according to manufacturer directions. I think that's important. One of the things that I think, I haven't really mentioned it recently. We talked about it quite a bit a long time ago, and even when Dr. Glander was here, but I think this is, sulfur dioxide is one of the most important things to pay attention to from harvest to bottling. It's critical in producing quality wines that are free of fault. And I think this is for all commercial wineries, regardless of size or experience. And this really, I'm not going to go into a lot of detail on SO2 other than the essential times here that we want to add. So to the crushed grapes or must. And again, this is based on conditions, the pH, that type of thing, on the amount that we're going to add. Immediately after alcoholic fermentation, again, it's dependent on wine style or variety. If we plan on going through ML, obviously we're going to wait till the sulfur dioxide is added till malolactic is complete. And then wine storage, we want to make sure we analyze and treat at intervals to make sure we stabilize that SO2, that it's protecting from wine spoilage during aging, which can be a significant time for spoilage to occur, or oxidation. And then at bottling, just adjust to 0.8 parts per million molecular. I think 0.6 is acceptable for reds, especially dry reds with lower pH values also. But you know, a lot of times when we do see faults, really a majority of the time it's because of low sulfur dioxide levels, and that we weren't monitoring and maintaining those levels. And a lot of times when we do rectify, it does include the addition of sulfur dioxide, and that may be before or after or both, whatever protective measure or reactive measure we're doing, pending on the fault at hand. But on the other hand, you know, we can have sulfur dioxide levels that are too high, and that's important to know. It can cause that pungent aroma. It envelops our delicate varietal character that we're looking for. So I think in light of that, I think it's important to keep lab analysis and proper application critical. We need to know where we're at exactly on these levels and base it on pH. This is just simply a graph that I believe we've probably all seen, but shows the importance of pH in the free SO2 to equal 0.8 parts per million molecular. So as we increase in pH, we really need more free SO2 in there to be effective against microbial activity and oxidation. Oxidation or oxygen uptake's another area where I think that you know, we actually have studied that pretty hard recently on some good surveys and presented that information. So I'm only going to say there are some benefits for oxygen and hyperoxidation, which there's some argument that might not be the most effective practice that I could talk about later. Alcoholic fermentation, the yeast obviously need oxygen to create the right biomass and for successful fermentations. And then microoxidation, we might talk a little bit more about next week on red wines, but it's really detrimental from wine quality from after fermentation through cellar aging, bottling of table wines. Really comes through both enzymatic and chemical oxidation, as well as microbial issues that are aerobic, like acetic acid bacteria, film yeast, Brettanomyces. And again, these can all be problems during wine aging, also fermentation, but during wine aging as we have coming up now in our cellars. So we want to limit oxygen exposure. It can entrain in our wine at lower temperatures more, so that makes cold stabilization more important as we're maybe going through now. We have to have SO2 levels up before cold stabilization, so that way when we come out of cold stabilization and the wine warms up, we're not going to oxidize our wine more rapidly. But when we have potential for high oxygen pickup is anytime we move the wine. So racking, excess headspace, pumping, filtration, and bottling, all these can be problematic. So in light of that, we need to keep tanks full, fill tanks from the bottom, inspect for leaky pumps, seals, secure any loose hoses, connections, or fittings, and then importantly, use appropriate inert gas for purging those lines that we're going to move the wine with ahead of time, get all that oxygen out, as well as the receiving vessel. These are sources for high oxygen to enter the wine prior to movement. This just shows the importance of temperature on bottom tank pumping or moving, where we see almost a threefold increase on pickup of oxygen just due to temperature. So that way it's important to maybe warm our wines up a little bit prior to movement to help refrain from picking up too much oxygen. If it is too high before bottling, then we can actually sparge it with an inert gas. I think nitrogen really is probably the gas of choice there. But these are just recommended levels that we want to go into or know after bottling. So red wines, typically less than 1.25 milligrams per liter or parts per million, whereas white blush or rosé are considerably lower at less than 0.6 parts per million. And I've seen coming into the bottling tank levels considerably higher than that, which is a concern already. And then just monitor, maintain pH, make sure it's at 0.8 parts per million. And we account for any oxygen we're picking up at bottling. Or if we want to potentially extend shelf life on that wine. I'm not going to touch about fining and blending other than to say that these are two important procedures that I think, especially with blending, that are underutilized in the Midwest and Eastern sections, and really probably all wineries across the states. But we can make good wines even better through effective fining and blending, as well as making wines that might have slight flaws more acceptable on the consumer acceptance level. But we could have an individual topic for that, and we have in the past also. So bottling line sterilization, these are some of the last slides here. I think that's critical, and we really need to be most efficient to use steam or hot water. And this is really at 180 degrees Fahrenheit or greater. And that's just because although water-based compounds like sulfur, citric can be effective, they're just not as effective because they can't the inability to penetrate some of the cracks, the submicron crevices that exist in bottling lines. Whereas with steam and hot water, we can actually heat that whole element to those temperatures, which is going to kill the microbes in question or that might be present. And then sterile bottling is the other part of that, where filtration is the most important thing, really. So, and for white wines, I recommend sterile filtration at 0.45, which is an absolute or membrane filtration. Where I think reds, we can go up to 0.6. We'll talk about that a little bit next week. That's not saying we might not get some daughter cells to come through, but if the wine is dry, lower pH, it's gone through malolactic, I think we're okay at those levels of filtration. But it's important to be able to perform a bubble point test. That way we can say that, hey, we know that filter is working as it should be, and it's according to manufacturer specs, gives us a sense of security. We can add potassium sorbate. I would say don't substitute it though for sterile bottling, but it can be if we're unsure of our sterile bottling or sterile filtration practices, then I think we can use that as a secondary source so that maybe we're able to sleep at night, especially with wines that have higher residual sugar. And the last slide, just keep in mind that laboratory analysis is extremely important to follow wine quality from harvest to bottling. We have essential analysis that I think we all must be able to perform in the lab. Then some recommended ones that I think are critical. that we need to maybe get up to date on that can certainly help us further in wine quality. And last, maybe some desirable analysis. And these could be ones that maybe we're sourcing out to a private lab. So with that, we covered a lot of information, but covered a lot of topics that we typically may approach at these post-fermentation workshops. Um, so I just want to end there. And I think we're going to open it up for questions.